Hello and welcome to Zetec's webinar on improving non-ferrous tubing inspections. My name is Wayne Waxman and I'm the Director of Marketing here at Zetec. I'd like to thank everyone for joining us today. I have a couple of logistical items before we get started. Everyone is in listen-only mode and we are recording today's session so you can review or share with your colleagues in your organization. Everyone who registered for this webinar will receive an email later this week with a link to the recording. During this webinar, there is a video segment. With GoToWebinar, when you play a video, the audio or the sound portion of that segment will only play through the computer speakers. If you are listening to this webinar over the phone, unfortunately, you will not be able to hear the sounds during the video segment. If by chance you can't listen through computer speakers, the video does have a few subtitles, so you'll be able to see some text of what is being said. Finally, we're going to have a Q&A session at the end of this webinar where we will be answering your questions. But you don't need to wait until the end of the webinar to send in a question. If a question comes to mind at any time, just type it in the questions box on your GoToWebinar panel. Before I turn this over to our presenter, I'd like to give a quick overview of Zetec. Zetec is a global NDT leader. For nearly 50 years, we've advanced the science and standards in both ultrasonic and eddy current technologies, setting new heights in inspection performance, productivity, and predictability. Zetec's proven expertise and complete product portfolio serve the inspection needs of our customers worldwide in transportation, power gen, manufacturing, and oil and gas. Zetec is a subsidiary of Roper Technologies. Let's get to today's presentation. I'd like to introduce Tom Odell with Zetec. Tom has been involved in the development and implementation of eddy current technologies with Zetec for the past 4 decades. Tom has held the position of engineering director, chief engineer, and product manager for Zetec during his tenure. Tom's current role is general manager of RevoSpec and EddyNet software business for Zetec. With that, I'd like to now turn this webinar over to Tom.
Thank you, Wayne. I'd like to welcome everybody to today's webinar as well. I'm really excited about the technology I'm about to share with you. I've prepared a following agenda here to guide us through our presentation today. First, I will briefly talk about the challenges we have seen in the way inspections are typically performed today. Then we'll talk about some of the enabling technologies within the system we are speaking of that make it perform very well. From there, I will queue up a video with Jerry Park from Zetec to demonstrate the system in action, where you'll be able to see the true value the system can provide. From there, I'll explain alternatives and options to consider. And finally, we'll wrap up with a summary and we'll take your questions. Over some time in observing how inspections are accomplished in the current heat exchanger market and receiving feedback from individuals close to these inspections, we have collected a list of some of the challenges that the customers face every day. After collecting this input, we have distilled it down to the following 4 attributes where we feel Zetec is in a unique position to offer some relief to these challenges. Regarding manpower availabilities, the inspection of heat exchanger components worldwide relies on the availability of specialized inspection resources to perform the work. In many cases, short notice scheduling and competing job challenges the deployment of these resources. In addition, components may be located in remote installations requiring more time and effort to mobilize teams. When it comes to the time to perform the inspections, technology applied to the inspections of heat exchanger tubing has remained relatively unchanged for many years. A high reliance on manual processes results in inspections with high labor content. This in turn can cause performance inconsistencies and prolonged schedules due to human performance variation alone. Poor performance from service vendors elevates quickly within the view of utilities and asset owners. With higher expectation on asset performance due to competitive energy pricing and operational goals, asset owners are demanding fast and competitive delivery of inspection services to get these assets quickly back online. Vendors striving to meet these challenges and provide fast and competitive inspections are at risk of performance issues when humans are placed in stressful service. The time to complete analysis and final reporting is on a critical path for the asset owners to disposition the component and return it to service. The service vendor is typically working with manual processes and tools and has lots of pressure to produce the final results and little ability to improve it over time. Often the final report is delivered late than the asset owner would expect. These are the key challenges we will address in our presentation today. At today's inspections, we commonly see a team of 3 people with individual responsibilities to perform the vessel inspections. This is common for heat exchangers ranging from hundreds to thousands of tubes. Today I'm going to use a couple of graphical depictions to illustrate what I'm talking about. In this illustration, the first person, starting on the left, is what we'll call the acquisition probe holder. His responsibility is to either hold a conduit to direct the probe into the desired tube if a probe pusher device is being used, or push the probe manually into the tube to be inspected and withdraw it at a constant speed while the data file is being recorded. Moving to the right, the second person is the acquisition operator. His primary function is to run the acquisition software. He is in tight communication with the acquisition probe holder to coordinate the recording of the data when the acquisition operator moves the probe and synchronizes the tube location being acquired. The third person in the team is the data analyst. His obvious role is to analyze the data coming from acquisition. Depending on the job, there may be several teams like this deployed to inspect the multiple vessels in parallel. The data analyst is commonly in a trailer or a building where the data from the acquisition team is passed via a USB drive that is hand delivered. The frequency of data delivery varies, but in many cases it's around 4 hours or a complete shift. As you can see, this sets up a batch cycle for the analysis activity, causing a built-in delay after the completion of the acquisition. This leads to about an 8-hour delay to wrap up the analysis and complete the preliminary report. The final report is often done off-site for convenience, and in some cases can take up to 1 week to submit. In this example, we're looking at more than 1 week to produce the final results for the inspection. Improving inspection cycles for cases similar to this example can provide great value to the asset owner. So we started looking at the tools we have to work with, and if we're going to help the customer lower their total cost of ownership, our thoughts going into this were we just needed to provide a little innovative nudge with technology to make the current systems work a little better. This evaluation also brought us to reconsider not only the tools, but how these tools are being used today in the inspection of heat exchangers. We didn't have to go too far into this to discover there's a lot of inconsistency about how systems are deployed. Now here's a list of what we broadly see used in the data acquisition components. Obviously common was the use of an eddy current instrument and software to operate it, along with an eddy current probe. What wasn't common was the use of a probe pushing system. We clearly believe that if we're going to improve on performance and consistency, we have to be controlling or addressing the uncontrolled variables in the system, and the practice of manually hand inserting and retracting the probe has to be an area of gain. Not to mention the cost of having a dedicated person just to perform this function while another person operates the acquisition software. Now I know there's some justifiable arguments to not use a probe pusher in bundles where small quantity of tubes exist, but just hang in there for a few minutes while I show you what the ProPusher brings to this discussion. Data analysis in this area has the largest diversity of approaches. There are very simple approaches from a single party manually analyzing data while keeping notes on paper or spreadsheets to a more sophisticated approach where they may be using two-party concurrence in the analysis process and harnessing data management tools to aid in the inspection, tracking, and the analysis reporting. Some of these scenarios may even be using automated screening tools for the analysis. Now, the use of automated screening is definitely heading in the right direction, but most of the tools out there are quite rudimentary and not capable of making a real difference. This is why I'm describing the need for a high-performance automated analysis software on the team. The integration of all components into a final solution is really where we discovered the largest gain is to be made. What we discovered is when we started integrating the best of our tools together, we really had something of value. Aristotle said it very well, the whole is greater than the sum of all its parts. Once we started seeing the solution we were creating from the performance perspective, we realized that we have the capacity to create a disruptive solution for this market. As with most modern systems today, integration is typically at the software layer where the user interfaces, workflows, or communications are tied together. This is where we applied our focus. What we are introducing is software-enabled integration that incorporates velocity acquisition, velocity data management, and RevoSpec auto analysis, some of our existing tools. We call the solution RevoHX. When coupled with the acquisition hardware, it creates an efficient workflow model that really makes a difference in the inspection. This integration was able to leverage some of the existing key technologies from across Zetec's multiple product lines, including some that serve other markets. Let's revisit our model of the inspection. This time we're going to explain it with the RevoHX solution. We'll start off with just a single operator and illustrate how the system can perform the entire process of what had previously been done with 3 people. We will equip this one-man team with an eddy current instrument, ProPusher, bobbin probe, and RevoHX. Again, remember, RevoHX is the integrated software that performs acquisition and analysis. As RevoHX is going to both acquire and analyze the data, we don't have to deliver the data periodically to the analysis team and the trader. The acquisition features are going to manage the probe movement in an efficient and controlled manner, and the analysis features are going to process the acquired data automatically. This lets the operator focus on probing the tubes. With this model, we expect nearly 100% improvement in efficiency, so the acquisition of the data can be accomplished in around 8 hours compared to the previous model of the manual system and 3 people that consumed about 16 hours or 2 days to acquire all the tubes. In reality, the analysis of the data is nearly instantaneous with acquisition, analyzing in around 15 seconds per tube. How do we know this? Well, we deployed a prototype system like this at an oil and gas facility this spring and benchmarked the performance of both the manual and the RevoHX models. With the analysis processing nearly at the rate of acquisition, preliminary reports can be produced in about an hour. Well, how do we know this? Well, the same oil and gas deployment, we used a direct reporting feature of the software to deliver a PDF document with the analysis results. For the final report, the operator can review the analysis results and provide some oversight to then produce a final report in about 8 hours. Well, how do we know this? Well, same thing. The RevoSpec analysis technology embedded in the system has advanced decision-making logic to disposition the detected indications into a final answer automatically, allowing for direct processing of the report. So now we're looking at a model that improves what would have previously been about somewhere over a week to about a 2-day cycle start to finish. To achieve the level of automation we needed to meet our performance goals, we had to provide more interaction between the components at the subsystem level. One of the key integration features is landmark analysis directly within the acquisition model of the software. The ability to identify landmarks during acquisition allows for the programming of events to be triggered based on the position of the probe within the heat exchanger tube. Another key integration feature is the communication between the acquisition and analysis module to allow the system to initiate analysis autonomously. I'll provide some detail on how these features are integrated into the workflow model. To start with, I will explain the automation behind the acquisition process. Once the system is set up in the auto mode for the acquisition is active, the acquisition cycle is going to initiate automatically when the probe enters the tube. Once the operator inserts the probe into the tube end, the system will sense the signal from the probe, and at this point, the probe pusher will be engaged. The probe will travel until it reaches and detects the far tube end. The probe pusher will stop forward travel in reverse direction, and the acquisition testing speed will start in the recording of the data. The probe will travel down the tube and look for the new tube end closest to the operator. The probe pusher and recording will stop when the system reaches its near tube end. Now the system is ready for the next tube to acquire, and the operator did not have to perform any keyboard entries. The benefits of auto acquisition technology are no doubt clear, but I'll sum it up this way. Automating the workflow through this technology allows the operator to focus on the inspection plan and less about where to stop and start the probe pusher and record the data. The net result is more consistent acquisition of eddy current data, improving the data quality. The second key benefit is the improvement to human performance, where the operator has fewer tasks and less fatigue, and therefore is less likely to make mistakes in the acquisition process. Letting the system take care of some of the redundant duties frees up the operator to focus on the critical duties. Another enabler through automation is the handoff between acquisition and analysis to start the auto analysis sequence. As I had mentioned, the RevoHX solution is an integration of existing Z technologies into a tightly controlled inspection process. In this case, we're talking about the automated workflow model utilizing velocity acquisition and RevoSpect analysis within the RevoHX framework. The workflow model is based on several automated trigger points to initiate steps in the RevoHX workflow. This all happens behind the scenes, but to get an appreciation of what's occurring, here's how it works. At the end of the acquisition sequence, when the probe exits the tube and the recording of data stops, a file is created and dropped into a defined raw data file folder. This is on the hard drive within the RevoHX system. The Revo engine that is already running and watching for the arrival of the new data will start the analysis process once this data file is submitted into the processing engine for the analysis, along with instructions on the analysis process, which we call the configuration. Output of this analysis is reported into a database to be ready for final reporting and review. Speaking of the analysis, I'll give a brief description of how analysis occurs within the Revo technology we have integrated into RevoHX. Z-Tech has approached auto analysis in a very methodical way. We developed a modular analysis structure where we are in the signal processing space, and we define the mathematical equation used to find, quantify, and report specific flaw types. We call this equation the analyzer. In fact, considering that the data can be influenced by other conditions such as noise, deposits, etc., it's a good practice to have various analyzers for a given flaw type to ensure good performance. This can be very handy to have all these multiple analyzers grouped together so they can easily be assigned to targeted regions of the tube. We call this grouping the analysis capsule. For each heat exchanger that gets inspected, it usually starts with some knowledge about the flaw types to be detected and reporting. Within our analysis capsule methodology, we put together an analysis configuration. This contains all of the capsules you need for a particular inspection, all pretty neat and tidy. Zetec is building an extensive library of capsules for customer use. When a customer implements a capsule from Zetec, there's a simple interface where the user can make adjustments to the capsule to modify its performance to meet their needs. Now that you have an understanding of the principle of the analysis capsule and the configurations that contain them, I'll explain how they get used to perform the analysis in RevoHX. The analysis configuration for the inspection gets loaded into the analysis framework when setting up the system for automatic execution. When eddy current data arrives from the auto acquisition process, it's paired up with the analysis configuration and sent to what we call processing nodes for the analysis. Depending on the analysis requirements being used, there may need to be applied to a flowchart decision process on the initial analysis results. There is a final acceptance model that lets you configure these logic rules and keep the whole process automatic. All of the final answers are reported to the results database and ready for final reporting and review. With auto analysis, most of the complexities you may be used to when manually analyzing data are taken care of it for you automatically, so you end up with a simple user interface that we call the dashboard. The dashboard is cleanly organized with calibration groups on the left side, data files for each of the calibration groups in the front and the center, and some common operational controls that are located at the top as icons. Here the user can calibrate the data, assign the analysis configuration, and start to run the data. The dashboard is a control center for the auto analysis in that it provides the operational control as well as status to the operator when the system is detecting problems with the analysis. Today we're going to show you a demonstration of the RevoHX solution in action. Before we start, I want to explain what you'll see on the screen. We have organized 3 separate feeds coming into a single screen so you can appreciate the actual speed of the process as you see the actions occur. In the upper left, we have the acquisition software, which is a screen from RevoHX. Below it, on the lower left, we will have the auto analysis software screen from RevoHX. And to the right, you have our data room where Jerry will be operating the system. So right now, we're going to have Jerry Park provide you with a demonstration of the RevoHX system in action.
Hi, my name is Jerry Park. I'm a sales engineer here at Zetec. Today I will be demonstrating for you our auto acquisition and analysis software, RevoHX. And here I have our acquisition system, which consists of our eddy current instrument, our probe pusher, and the probe pusher has a bobbin probe installed. I will be testing this mock-up tubing, which has several support rings to simulate the support structure and the tube sheet. And to bring it all together, we have our Rebel HX software on this laptop. And I will describe to you in more detail the software later on. Okay, now to start the acquisition, all I have to do is press the record button, and now it's ready to start. Once I insert the probe into the tube, it will automatically detect that it's inside the tube and start going forward. And once it reaches the far tube end, it will stop and then start recording in the reverse direction. And then once it reaches the near tube, it will stop and then get ready for the next tube. Now it's in the tube, it's going down to the far tube end. Okay, detected the far tube end, now it's coming back and recording. Now it's ready for the next test. It's going down the tube. Detected the far tube end, and now it's recording. And now it's ready for the next tube. Let's take a look at the acquisition software. This is our acquisition software. On the left, we have our strip charts. Over here on the upper center is the LISIJU screen. Below the LISIJU screen is the expanded strip charts. Over here on the right, we have our pusher control buttons, as well as the acquire button and the record button. Below the control buttons is the test plan, which shows a list of tubes that we are recording. It also displays the status. Once the tube is recorded, the status will be tested, and it will be highlighted in green. The tubes that have not been recorded yet, the status is not tested. Up here, you can see the row and tube encode numbers. That is either the tubes that are being displayed in the data file, or when you are recording, it will be the tube that you are recording. Okay, now let's take a look at analysis software. Here we have our analysis dashboard. Over on the left displays the cal groups that we have loaded. Over here we have some control buttons. The first one will take us to our auto calibration function of our analysis software. This is for setting up the analysis. The second button will load the auto analysis configuration. The next two buttons will start or pause the analysis process. And the last button will take us out of the cal group. Down below, we have a list of tubes that are being analyzed. And this can be run real time, so as tubes are being recorded, you will see them populate in this list. We have some general status of the analysis, as well as the status of the analysis process for each tube. Now, the black icons are for the data files that are non-tubes, such as the summary file or a message file, and also for the calibration standard pulse. For the data files that are to be analyzed, there are several different status icons. A yellow status represents tubes that are waiting to be analyzed. Once they are being analyzed, the status will turn to blue, and then once it has successfully completed the analysis, the status will turn to green. For those that have failed the analysis for reasons such as data quality or locating issues, those status will turn to red. All right, now let's see everything working together at the same time. You should now see a split screen with the acquisition software over on the top left side and the analysis dashboard over on the left
bottom left side. Now, I'm going to go ahead and start my acquisition. And we can see how everything works together in real time. Okay? So in the acquisition software, you'll see the data scrolling. The color is green, and then the color changes to blue once it starts recording. Okay. And then over on the test plan side, you can see the status of that tube changing once it has completed recording. And then you can also see the encodes update to the next tube as I complete the recording. Okay. Now over on the dashboard side, you can see the list of tubes there. As I'm recording the data, you will see new tubes populating in that list. And you can see the status of the analysis process. So you should see another tube populate, and it's being recorded, and now it's complete. All right. So the process is very fast. You can see here I can go from tube to tube fairly quickly, and the analysis process keeps up without any problem. Okay, and I'll do a couple more here so you can see everything working together, and you can see that it's very fast. Yeah, I'll do one more for good measure. All right, and there you have it. Now let's take a closer look at the analysis software. All right, so here on our dashboard, you can see that there are some reported indications. They all have 3 indications because obviously I was testing the same tube. The mock-up tube that I was recording has some flaws we put into it. So let's take a look at those flaws. Here, I'm going to bring up my report editor. So this is a list of all the reports that the analysis software made. You can see that there are 3 entries for each tube. Now to bring up the report, all I have to do is double click on the report of interest. And then you can see that it will automatically load into the analysis software. So here you can see the indication that the software called and how it made that call, such as channel and what kind of measurement it made, and the indication code that it used. So here, we can flip through each indication by using this button, Next and Previous. So if I do a left click on the mouse, it will go to the next indication in the report. And if I do a right click, it'll go to the previous indication in the report. And this way I can cycle through all the indications and review everything that the software has done. Okay? And then you can see it automatically loaded the next tube. And so on. Now over here on the left-hand side is the display of the tube regions and the landmarks. Once this is configured correctly, the software will automatically locate all the structures when the data file is loaded. In this way, the software will properly mark the location of the indication in reference to the landmarks. This concludes the demonstration of our auto acquisition and analysis system, RevoHX. Thank you for watching.
Well, great. I hope you saw some pretty cool stuff there. I think you have starting to have appreciation to understand the benefits to what can be gained by the RevoHX solution. For some, an immediate change in process to a single person may be a bit too far of a reach. For instance, there may be some insecurity by having a human in the process of doing the analysis. In this case, the RevoHX system can also operate in an assisted auto analysis mode. The auto analysis portion of the software can be run on a separate computer. The RevoHX dashboard can manage multiple cal groups at the same time and be operated by the job analyst. In this scenario, the analyst will receive the data files passed from the acquisition team and initiate the activity to monitor the auto analysis. The left pane will keep track of all the progress and notify the analyst of any exceptional condition. During the analysis, the analyst can interactively review all the reported calls and provide oversight. We have our traditional analysis tools available to interact with the calls being made by the automatic process, and the analyst has full control to apply additional expertise to the analysis of the data. The important point here is the analyst is only reviewing the reported calls made by the automated process and not searching the complete data files to detect and report flaws. This is a huge savings in time and effort and allows the analyst to provide value in a focused area. Now, of course, we believe the interactive process may be unnecessary given the performance of the automated analysis process and system. However, we also believe that providing flexibility to the operator in this hybrid model may be an important step for some in adopting new technology. I know we're approaching the end of our session today, and I wanted to introduce you to one last feature optionally available with RevoHX. For some, you may be familiar with our HDC or historical data comparison software. This technology is used to compare two sets of data to evaluate change on a signal-to-signal basis. The software technology uses your existing data along with up to 2 previous sets of inspection data. Typically, this is the previous inspection and the baseline inspection data. In this example, we will represent the current data in green and historic data in orange. Processing automatically aligns and correlates this data so that the result is data points of the differences between the 2 inspections. These data points and these signals can be processed to create what we call a delta channel. The delta channel is an important feature in that it is like a process channel, and we can run this through the automated RevoHX process for analysis and use it as a detection of change. Another feature is when the data is presented in the user interface, we have the ability to overlay signals of interest. In this example here, you can see for the given signal, we'll start in the upper left box where we have both current and baseline loaded together in an overlay. An important feature of HDC technology is it allows us to apply a common configuration to both sets of data, so the relative change between the 2 is already calibrated consistently. Moving from the top left to the next box over is the baseline delta. Now this is a subtraction of those 2 signals you see on the left, and essentially it's what's being used in the automated analysis process for detection. The third box over is a combination of both current and historical. So this would be an example of 2 data files that are most closely related in time compared to the first one where it went clear back to the baseline data. Now, what's interesting about this signal into the untrained eye and without the overlay in comparison of the common calibration, it would appear that the signal has not changed. This is a very historical signal known in the industry to have actually stifled quite a few analysts in detecting change because the signature relatively remained unchanged. However, there is a small amount of change delta, as you can see on the fourth box top right, which we call the history delta. Now, this resulted in what amounts to a 0.2 volt change in the data. And the HDC automated system not only can be used to detect that change, but to bring you this calibrated overview point so you can evaluate the change from an analysis point of view. So getting back to where we started in the beginning, addressing the challenges, we identified a few of the inspection challenges that we believe automation can address. At this point, I think you may be starting to understand how our RevoHX-based solution can meet these challenges. Addressing manpower availabilities with the RevoHX-based system is clearly achievable when we are able to significantly reduce the amount of resources needed to perform the inspection through the automation. In addition, the training required for these resources is more unified and not necessarily independent roles. When it comes to time to perform the inspection, it's another success with the RevoHX-based system. When you hand over the mundane and redundant processes to an automated system, you remove fatigue factors and the associated human errors that result. This eliminates costly retesting of tubes and keeps the inspection rolling at a predictable pace. While we humans are great at doing tasks, we aren't so great when we are doing the same task over and over again several thousands of times with no diversity in between. This is what occurs when performing the inspection on several thousand heat exchanger tubes. Couple that with the expectations on schedule, and the level of performance from the service vendors can start to be impacted. Applying automation helps to address these conditions by removing the critical task of repetition from the humans and placing it with an automated system. Now we have seen that the analysis of data is provided close to the acquisition process. The time to complete the analysis and reporting is no longer a follow-on activity, but available right away following the inspection, clearly addressing this challenge. So we've reached the end of our prepared webinar on the content.
So on behalf of everyone at ZTech, I want to thank you again for attending this webinar. If you are interested in learning more about our solution or have additional questions, please email us at marketing@ztech.com. And of course, to learn more about ZTech, visit our website or follow us on social media. As a reminder, you'll receive an email with a link to the recorded webinar shortly. This concludes our presentation. Thank you and have a great day.